Hello, everyone. Welcome to FHE on Chain podcast. It's Furkan from Inco Network, and I'm working as a researcher and a technical content creator there. Today, I'm having Peyman from Fairblock, and we will discuss things around confidential compute, MPC, and obviously what Fairblock does, and some possible use cases around privacy, around confidential compute, and many further things. So, welcome, Payman. First of all, thank you for being here with me today, and I hope it will be a fun chat.
Yeah, excited for the chat. Thank you for having me.
Yeah, so I would love to start with who you are and what your background is. Could you tell me a bit about that?
Yeah, of course. So my name is Peyman. I'm founder of Fairblock. And before crypto, most of my background was in privacy preserving machine learning. So I had like some time working on in my undergrad and in like Iran in Sharif University and Hong Kong University of Science and Technology on leveraging things like TEE and NPCs for applications like ride-hailing applications, like psychological chatbots, like we are seeing it today with ChatGPT. And in all of these use cases, there's a lot of like basically privacy of the data is a blocker for the applications. So I was working on them, and then like when I started my grad school in URLU, it was my like official intro to the technical and engineering challenges in blockchains. And I was very early on in MEV problems, and I introduced like MPC as a solution for like threshold encrypted mempools to prevent front runnings. And then based on my work in my grad school, we started Fairblock, and then we grew the vision to where we are today.
Yeah, that sounds really interesting. So let's start with Fairblock. How would you describe Fairblock and like what kind of problems Fairblock actually solves or will solve? So please do not hesitate to give more details. I would love to learn as much as I can.
Yeah, the official way that I describe it is that Fairblock is enabling dynamic confidential computing to build fair and credible economies. So that's like the official way. But it's better to talk about the applications and what's in it for users at the end of the day. Some applications that we are really focusing internally with our partners is dynamic and fair price discovery in intent protocol, token launches, and RWAs. And the other example is fixed rate lending markets and confidential clearing markets. The third example is confidential and undruggable AI. And the last example is private and compliant transfers for institutional users or like normal users. And
Yeah, please.
general, like, sorry, the general umbrella that we like to talk about is credibility and manipulation free, because right now we are in the like basically in the position that everything is going towards centralization. We just throw a server or like a TE to every use case because there's a lot of challenges on chain. And some of the challenges we can see that it's not like just made up. We can every cycle we see like bad MEV, we see like manipulations in Solana, and even today in Hyperliquid, you can see that users are trying to manually master transactions. And what's the reason for that? It's not anonymity of addresses. It's about we've built a system that is fundamentally broken in the sense that we are leaking all of our actions, and there's all kind of people who are like privileged or wiser or faster than other people to use that bug in a way that doesn't provide actual value to the system, right? So at the end of the day, we want decentralized but manipulation-free systems, and the path toward that is confidential computing in a decentralized way.
Yeah, I think it was a great intro. So let's talk about a bit more details. Like, okay, Fireblock wants to solve these problems and make it a better infrastructure in terms of the mentioned problems and issues. So how actually Fireblock solves these problems from the technical standpoint?
Yeah. From a technical standpoint, our focus is on MPC because at the end of the day, when we want to have an actual decentralized confidential computing, somewhere around the stack, you need MPC, right? And MPCs are not just like MPC is not a thing. MPC is a problem, and there is different schemes, cryptographic schemes that you can use for solving the problem, and there's all kind of trade-offs between them. So Fairblock is like a network that all of our validators can have both cryptographic and economic security to act honestly, and we orchestrate the best kind of cryptographic solution for each of the applications. And that's where the term dynamic comes from, because we want to optimize the solution in terms of performance and security for each applications. In some cases, you want to have like almost immediate encryption on the user side. You want like low bandwidth overhead on the backend side, and the security guarantees is not that high. Like then, like because the application itself and even the safety of the funds are not requiring that much security compared to the privacy part, right? So we can have like an ultra performant application for that. In some applications, we can take a little, like spend a little bit more in terms of time, like money, computation power, and have higher guarantees. So the way that I like to describe is that we are building like a network that have different tools, and in some cases there is always like an optimized tool for each task. So in reality, when you want, like, you don't use a hammer um, for like a screw, and like there's a screwdriver. So fundamentally, solutions like TE, MPC, and ZK are designed for different challenges, and sometimes they can be there's a trade-off between them to solve the same problem, and sometimes for harder problems you need to combine them. So I like the term multimodal solutions. So there is basically, last time that I counted, there's 20 ways to combine MPC, TE, ZK, and FHE to solve bigger problems with a combination of them. And this is like where we are going, but we are focused more on the MPC side, especially threshold FHE CKKS and threshold IB. And that's where we are starting. And we have like some elements of ZK and TE on the side to add some features.
Like, that being said, maybe it would be good to expand on like the final notions that you mentioned, like threshold CKS, threshold IB. It would be good to expand on them for our listeners, maybe.
Yeah, of course. So threshold IB is basically threshold identity-based encryption. Historically, it's been used for encrypting your uh, data for specific identities without any public key infrastructure. But the way that we are using it is it's close to the concept of witness encryption or conditional decryption, which means that we can encrypt our data toward certain conditions on chain or like off chain. So, for example, when you encrypt your transaction, it can be decrypted when like your stop loss trigger has been met, or like the time for your transaction is met, and your data while it's resting is protected against like front runners, other manipulators. Another example of that is in seal bid auctions. So like you encrypt your bid, and there is no centralized auctioneer, and once the auction is done, we can decrypt and execute the auction. The good thing about threshold IB is that on the user side, the performance is like really good. It's like really seamless, and we can have it in the front end of the application seamlessly. It takes like few milliseconds to encrypt. That's great compared to like many other solutions. And on the backend side, since we can have the concept of batch decryption, the bandwidth overhead and the time for decryption and execution is much lower. And threshold CKKS is our bet on the FHE side because it's like open source, and we can have our current network for threshold decryption for the part that MPC comes to play for FHE. And we are using CKKS for applications that doesn't need DeFi application that doesn't need a lot of computations, but they need to be super performant in terms of time of the computation and the ciphertext size, and also on the confidential AI side, because it's like a better scheme compared to the alternatives when it comes to down to the applications that you don't want exact numbers, but you want something performant.
Yeah, CKKS is always the best choice when you're okay to deal with approximate numbers. So okay, we actually mentioned several things like MPC, IBE, CKKS, and of course in a threshold manner. So how Fairblock combines all of them to come with a actually concrete product, and like how it utilizes these different technologies.
Yeah. Basically, our validators, they have access. Like the cool thing is that at the end of the day, you need like a network for the multi-party computation, and our validators can run secret sharing algorithms between each other without any centralized parties. And those validators, they can have access to different schemes. So we can have like encrypted transactions using IB based on the application that IB is like the best tool for that. And then our validators, once the time is reached, they can decrypt the transactions together and execute them. Same thing for like even FHE. So since like most of the applications that we are touching in crypto is threshold FHE, at the end of the day, there is a need for threshold decryption and execution, and that's the part that our network is handling that. And we have like some codes that can basically encrypt the transactions in the front ends, and the execution and decryption happens in our network or like our connected partners.
So you're utilizing both MPC and FHE for making confidential compute possible. How does Fairblock differ from like the other existing FHE VM solutions like Inco and the others?
Yeah, one of the I think most important differentiations is that we don't have a co-processor for some of these applications, so we are not relying on a centralized party to compute over encrypted data and then optimistically or like using ZK proofs, proving that the computations was correctly done. That's like both of a trust issue and also some kind of friction in terms of the execution. And we really prefer to have like everything decentralized in our network. And when we collaborate with teams like Arbitrum Foundation and we have an application there is no centralized party involved in the computation part. Everything happens on chain as much as we can. And this is like a permissionless setup. So that has been really the composability of our solutions with other solutions for other applications, and uh, not having the friction of the core processor has been like a good selling point for us. That being said, for some stuff, it's like more efficient to have the core processors approach, but we are really focusing on simple but like really impactful applications that we can make it happen and bring the value of the applications like as much as possible today, rather than investing like for the next 10 years.
Yeah, before closing the infra discussion, I'm just trying to, visualize correctly how things work within the Fireblock protocol. So, like, from the developer perspective, like, who wants to, build a confidential application? So the app that they built, like, does that work on the Fireblock blockchain, or does Fairblock also enable confidential applications on the existing mainstream blockchains as well?
Yeah, we have both options, and there's always, as anything in engineering, there's trade-offs. The way that I like to describe is like a restaurant. So when you want like hot, fast, and efficient service, you go to the restaurant, and it's a dining experience. So we have our own chain, and if an application needs to be immediate, fast, cheap, and like it's like for a new developer or like a team that wants to build a huge project around that, I think it's like much more performant and secure and efficient and all of that in our chain. But sometimes when you have a big party somewhere else and you can't have bring all of your guests in terms of developers and users and liquidity to another chain, that has been an actual blocker for many privacy chains because they're somehow isolated, and we need to make it like in a composable approach for like other major chains. And that's why we've been investing a lot developing tools that permissionlessly and seamlessly can be enabled and composed with like actual applications, for example, in Optimism or Arbitrum or other Cosmos chains, to have uh, for developers to just like plug it into their applications. And at the end of the day, it works with our chain for the MPC part, but the execution of the applications in those cases doesn't happen in our chain.
So like let's
Like normally we have like an encryption library, right? That can be integrated in the front end of the applications. So users doesn't need to install a new wallet or like a Rust library and all of that. It's more of a developer side, very similar to HTTPS. Like users today don't know that 95% of internet is encrypted because developers has plug it in the HTTPS libraries, right, in their websites. That's like our vision as well. So users go to an application and while they're like trading, bidding, playing a game, or like selling their data, the data automatically gets encrypted, and then based on like where the execution happens, we take care of like satisfying the conditions and like decrypting them and computing over them and all of that in the background.
So, like, considering the latter case where let's assume I want to build a confidential app on let's say Arbitrum, and I want to utilize a Fairblock's technology. So, how does Fairblock achieve this, without having a sort of co-processor on Arbitrum?
Yeah, that's like a very interesting case about Arbitrum, because with Arbitrum we have a stylus, and a stylus is like an alt VM based on Rust. And the great thing about stylus is that like while you have solidity and everything, you can combine it in a like blend it with other VMs, right? So in this case, Rust. And the very interesting thing is that historically all of the cryptographic codes are in Rust because it's more performant and secure, and we don't need to rewrite the applications and like cryptographic libraries in Solidity, which is either like not secure or like very inefficient or like very hard to do, and we need to spend a lot on the auditing side, right? So in Arbitrum, we basically write our applications um, in basic like our smart contracts, our decryption contracts, and everything in Rust, and use a stylus to connect it natively with the applications that are there.
Would that approach work in Optimism or Ethereum mainnet as well, or some other solution will be needed?
Yeah, so that approach works with Arbitrum permissionlessly because we use stylus, just stylus, and it works for all of the Arbitrum Orbit chains and Arbitrum One. It also works with Optimism, but we need to have like another approach, which is pre-compiles. It's a little bit harder because you need to deploy the pre-compiles, but it's not that hard, to be honest, like because we can even do that for the partner teams, and we are doing that, and they can install the pre-compiles in like 30 minutes, and after that we have the same functionalities. It's not as great as the Arbitrum approach because it still needs the pre-compiles, but we can do that. With Ethereum and Solana, not Solana, but Ethereum and some other chains that we don't have the option with pre-compiles or like stylus, uh, it goes back to the basic way of co-processing, that we take the execution of the applications and send the end results to the other chains. And sometimes it makes sense, like other like cryptography teams that are also focusing on co-processing. But sometimes that's something that we are investing in that with Ethereum Foundation, and talking about that to basically enable the cryptographic curves and invest more in privacy preserving technologies to do that natively as well.
Yeah, that would be great actually, but like I mean, from like my personal view, my an observation is that like Ethereum community is not, like not willing to add more precompiles into the existing code, right? Because of, like gonna like just to EVM as simple as possible. But I think it's a really good thing to have several options, like the one in the Arbitrum stylus case, the one in the precompile case, and of course the co-processing approach. And like actually we don't need to choose one of them, like depending on the use case, depending on the like the infra choice. I mean, one of them can be used easily, I believe.
Yeah. So the way that I like to talk about it is that we are like basically we have a menu, right, for developers and users, and there's trade-offs. There's trade-offs between the performance, security guarantees, and developer experience, user experience, and there's no like 42. There's no answer for all of the problems in the world, and we want to be as flexible and dynamic as possible to really make applications work. Regarding Ethereum, I think we are in like an inflection point right now that obviously we know all of the dramas around Ethereum, and there's a question that while like all of the DeFi applications are somewhat migrating to their own app chain or like Arbitrum or like Optimism, and we don't have the degen culture in Ethereum that much anymore. Unfortunately, what's in it for like what's the like roadmap for Ethereum, right? And Vitalik is recently, like for the last few months, he's like talking more and more about MPC, FHE, TEs, and basically like one of the main things in the roadmap of Ethereum is investing in privacy preserving tech, right? So they can invest in the core processing path, they can invest in the pre-compose path, and it's like a step-by-step process, right? We have seen the same path with ZKPs, right? With ZKPs, we didn't have the pre-compose for Ethereum, like EVM, and then like with the proof for the traction and the applications, they added, and they are adding like more stuff, right? And I think this is my thesis for MPC, TE, like anything else on EVM as well. We need to prove the traction in app chains, in L2s, and other than that, and the Ethereum community will realize that there is a better way to do that natively. And there's always a push from the demand side, and they take the action. And another great example of that was DA. In the early days, they were uh, basically resisting against like native DA investment there. And with the Celestia, Avail, and other projects and EigenDA, there was the requirement, the demand, like suddenly natively that we need to invest that inside Ethereum. So that's the bullish case for privacy tech in Ethereum.
Yeah, I actually also agree. So, okay, I just want to, like to grasp like regarding the infrastructure as much as I can. And now I think it's gonna be very smoother to talk about use cases. And I think this is also be discussed as much as possible because like infra is good, but infra is for use cases, right? And applications. So
Exactly.
assuming we have these different options regarding the infra in our menu, now like what kind of use cases this like or these different options enable? I mean, I'm asking this apart from Fairblock actually, like in general from the confidential compute perspective.
Yeah. So the way that I think we should talk about confidential compute in crypto is like selling a car to the community, to developer community that hasn't been using cars and they're only seen horses. And it's a little bit challenging because like we are nerds, we love the technology, and we always talk about like, oh, like NPC, FHT, and like nobody really cares. They think it's just about privacy. Like privacy is a luxury. Let's build the application first, then yeah, like we'll add the privacy part. But it's not like that. It's more, without a car, you can't go to the next city. Without a car, like with a horse, you can just like wander around in your own village, right? That's the situation in crypto. After 17 years of investing $100 billion in startups, we haven't really seen that much applications rather than meme coins and the OG plain text transfer. And we know that a lot of applications today really need confidential computing as like their main feature. It's not even a feature. It's like a thing to build on top of it, right? Even the OG use case of blockchains transfers are somewhat limited today because a lot of normal users, even crypto startups or institutional users, they don't want to leak the salaries that they are paying to the other employee. They don't want to leak anything. It's not about hiding your addresses anymore. It's about like the numbers. It's about the amounts and activities. And we can see that even when Vitalik is donating ETH to science, people will make dramas around that. So that's not great. It's basically parking like your Ferrari in a public uh, parking station, and there is going to be problems, and we know that, right? Uh, and basically, let's talk about where we can go with the car. Obviously, cars are more private and more secure compared to horses, and that's exactly the same for confidential computing. Privacy is one of the features of confidential computing that people think that, oh, it's just about privacy. But let's talk about where we can go. What's the actual use cases, right? So things that I'm more excited about personally is intent protocols, both on the user side when you're expressing your intents. You don't want to necessarily like leak it to everyone. And also on the solver side, when they're bidding, when they're solving, they can do it in a more confidential way. And it's not about privacy. At the end of the day, it means better price discovery, losing less money, getting less exploited for the users and even solver side. And it means that there is like a cake, and right now we are taking the cake and giving some part of piece of the cake to people who are not bringing positive value. And by taking that part of the cake and dividing it with the people who are bringing value, users and developers and solvers, we can make a better system. That's like where I can see the intent protocols and the normal transfers we can bring value. And there's a lot of use cases that is really not explored in crypto, like lending markets. Uh, you can do it on chain and leak all of the activities, and you can do it inside a TEE that is proven to be not the exact best way for PMF, and like why we are building a blockchain, even if you want to do that. There is like another way that I think is practical. Is it doesn't have the problems that we've seen with like problem because of the with the performance and the cost, which is on-chain, right? You can use the things like FHE, MPC, and a lot of solutions to build DeFi mechanisms that were not previously explored on-chain. And that's like getting closer to the actual values of decentralized applications, building decentralized and manipulation-free ecosystems. And there's a lot of
Yeah,
other things. Like obviously, there's the AI side of the things. We are, I don't know, like it's somewhat hypes AI right now. It's unfortunately people think like it's just chatbots on chain, but that's not the actual AI that I'm excited about. I think I'm excited about things like private data marketplaces, bots that are trading, balancing your like portfolio, optimizing your investment in the vaults, and you don't want to leak your information to them, and they don't want to leak their models to you. So it's more about balancing the relationship between the end user and the company who is on top of that. And it's more about the monetization and the incentives rather than the privacy of data. And there's also like even games, right? Even voting. Like you don't want to leak your votes on chain. You don't want to leak your next move, your hand on chain, and like if the blockchain is only used for airdrops, that's not where we want to go. If the blockchain is used for the where the application is executed, that's where we want to go. But without confidential computing, we can't get there.
yeah, totally agree. Also, I'm also personally interested in the future of confidential compute as a use case in healthcare. Like,
Yeah,
because yeah, I mean, in the current status, like confidential, like in genetics, in like normal like the hospital like disease tests, everything is public, and like people seem like they're okay with it, but they shouldn't be, obviously. And I'm quite excited about the future of confidential compute, like from both FHE MPC perspectives, in healthcare, as you said, AI, and of course in blockchains. And like that's why we actually did our research with Circular Research on confidential ERC20. Maybe you've seen
yeah,
it before. And yeah, I do think like the number of these use cases and the methods that are used should definitely increase. Because like I mean, like it's actually quite easy to understand, right? Like I mean, I don't want to reveal my salary. I don't want to reveal my investments, like the positions that I opened on DeFi protocols. I know like in which tokens I invested in which tokens I removed my positions, and etc. Um, like before getting to end, I'm also wondering your thoughts on confidential compute in Web3 and Web2. Like
yeah.
in Web3, it's quite easier to like discuss, right? Like DeFi protocols, like payments, transfers, and other stuff. But what if in Web2? What do you think? Yeah.
Yeah, something that like people normally think that we haven't really invented cryptography in Web3, right? All of these MPC schemes, all of these applications, way go back in history, at least 30 years, 40 years of development of products. And there is clear product market fit in crypto because it's like monetary. You can actually see the value right away. It's less ideological, right? Uh, but even me, before crypto, I was working on privacy preserving, like therapies, AI models, like psychologists, that kind of stuff, and or like privacy preserving databases in the ride-hailing application that I mentioned. And in some cases, it's building something that is not against the complex regulatory issues. For example, in the EU and many other countries, so it's an actual blocker. Like if you don't have the privacy preserving database, you can't build the application, right? And it's very interesting that when I was working on that, it wasn't that performant, but we are getting there today. We basically built like a heading head of like a therapist head. It's like a robotic head that was talking with you in Hong Kong, and it has like some kind of deep learning model inside it, and you could have chat with it and talk about your psychological issues, and it could like basically do some stuff that we can do with ChatGPT today, and sometimes refer you to some kind of more like knowledgeable person. Uh, the good thing about that is normally, like at least in many countries, you are not totally comfortable with your psychologist, right? You are not sharing a lot of things with them because they actually leak your data, even though it's not their professional move. And uh, it's that part in psychology, but also like when you go to like a normal like doctor, when they ask about your like smoking patterns, sexual partners, a lot of people don't really share the actual um, or like maybe you are even ashamed to say that you don't exercise. You say like, yeah, I definitely exercise 5 times a week, right? So
Yeah.
even for having like a better indication of your like medical records and like what you should do in your life regarding your health, it's better to have confidential computing. It's not just about like the privacy of your data, it's about trusting the system, and you can't trust humans, unfortunately.
Yeah. Thank you so much. It was a really, really nice like chat. But our tradition is like before closing up, I'm asking your favorite book to recommend to our listeners. Given that you already referred once to Hitchhiker's Guide to the Galaxy, but yeah, I'm gonna still ask.
Yeah, I think my favorite book is um, not really related to crypto and technology. It's
Yeah, sure, please.
I think the title is On the Meaning of Life, and it's by Will Durant, the historian. And basically, he asked a lot of like scientists, politicians, like surgeons, like a lot of other people, basic to answer this simple question: What's the meaning of life? And sometimes they didn't even respond. Some people responded in 10 pages, some in just one word, and basically he collected like hundreds of answers and put it in a book with a nice intro, and it's really interesting to see how people with over 150 IQ think about life in very, very different ways, and some of them will resonate a lot with some people and some of them will not.
Yeah, I'm super interested. I definitely take a look at it like today. Yeah. Thank you so much for being with me today. And as I said, it was a really fun and I think a helpful discussion. If you have any final word, please do not hesitate to tell me.
Yeah, I'm very excited about all of the cryptography companies that we are basically privacy loves company. So there's at least five great companies who's been building in this category for the last like 2 or 3 years. In the very, very hard days, nobody believed in privacy and they believe in meme coins more. Right now, we are going back to fundamentals, and we like everyone, even the community, are interested in real applications, impactful applications, and definitely confidential computing is like the top category in the next cycle or the current cycle.
Yeah, totally agree. Okay, so thanks everyone for tuning in, and I hope it was helpful and fun. So see you in the upcoming episodes.
Thanks a lot. Thanks for having me. Have a good day.
Yeah, sure.